Hi guys, welcome to this lesson. So in this lesson, we want to look at the sine rule. So the diagram shows the usual notation for a triangle in trigonometry. So let's have a picture of a diagram, a triangle. So in this diagram, we have the angles are labeled as A, B, C. So those are the angle and there's vertices. So we have the angles are A, B, and C. Then we have the vertices. The side facing angle A is small letter A, the side facing angle B is small letter B, and the side facing angle C is small letter C. So the vertices are A, B, and C respectively. So the length of the sides are denoted by a lowercase letter, and it is named after the angle that is opposite the side. So A is opposite to angle A, and B is opposite to angle B, C is opposite to angle C. Okay, so and if we use same terminology, we also have the following. Okay, so remember that when you are naming angle, of course, this is a GSS1 work. So when naming angle A can be written as angle uh, angle what? Angle BAC, right? If we use this side, and angle B can be named as angle ABC, and angle C can also be named as angle ACB. Okay, naming angles convention. So this is what you have studied on angle from junior school GSS1. So from this triangle we can develop what is known as the sine rule. Okay, so the sine rule states that the sine rule states that A over sine A equals to B over sine B, which is equal to C over sine C. Okay, and what are the rules for using the sine rule? So uh, rule for using the sine rule are if you have two angles on one side. So when you have two angles on one side, you can use the sine rule. Okay, when you have two angles on one side, you can use the sine rule. And then when you have two sides and the angle opposite one of the side, so when you have two sides and the angle opposite one of the side, opposite one of the side, so you can also use sine rule. So these are the two conditions for using sine rule: two angles on one side, two sides, and one of the angle that is facing one of the sides. So you can always apply sine rule. So before we go on to using or taking example, as a general rule, if you cannot use the sine rule, if sine rule is not applicable, then you use cosine rule. Okay, so we've not gotten to where we are going to be solving cosine rule. So step of solving questions involving sine and cosine rule. So if it is not given, you must always draw the diagram and put as much information, put all the information that you have in the diagram, and then if two or more triangles are linked, you have to redraw the triangle separately. Okay, so you can't solve two triangles at the same time, and then you watch for the condition for sine, and if there are and if you have any of these two conditions in the diagram, then you use the sine rule. If you don't have any of these two conditions, then you have to use cosine rule. So when we get to the example under cosine rule, we are going to be taking cosine rule. Okay, and then you are going to see how it works in practice. Okay, all right, let's take example. So sine rule. So when you are solving problem, you are only to take one of the two rules. You take one of the two formula, or two of the formula. You cannot use the three at the same time. So always take two. So you can use AB or BC or AC, but you cannot use BP. Okay? Example 1. In a triangle, we have A equals to 8, B equals to 9, and A equals to 60 degrees. Okay? Find the possible values of B. Find the B, C to 2 to the nearest degree. Okay? To the nearest degree. So the first thing you should do is draw the diagram. Okay, represent the information of a diagram. Okay, so which angle do we have? We have angle A, so this is 60 degree, and the side will be 8. We don't have angle B, we don't have angle C, and then we have side B, which is 9. So can we use the sine rule? Yeah, we have two sides and one of the angle facing this side. So we can use the sine rule. So we are going to be using A over sine A. Okay, we're going to be using A over sine A equals to B over sine B. So substituting the values, we have 8 over sine 60 equal to B, which is 9 over sine B. We don't know B. Okay? So if we cross multiply, we have sine B equals to 9 multiplied by sine 60 all over 8. Okay? So taking our calculator, we have sine 60 is what? Sine 60 is 0.8660 all over 8. We have over 8 there. So multiplied by 9 divided by 8, and the answer is 0.9743. So therefore B equals to sine inverse of 0.9743, and that will be equal to sine inverse of our answer, which is 76.98. So B is approximately equal to 77 degrees. Okay, so that's what we have for this one. And then we can use sum of angles in a triangle to find C. Sum of angles in triangle, that will be A plus B plus C equals to 180 degrees. So 60 plus 77 plus C equals to 180. Okay, so C equals to 180 minus 60 plus 77, which will be 137 degrees. So and C is therefore equals to 43 degrees. So and then the solution is complete. So as easy as that, that's how you use the sine rule. So therefore B equals to 77 degree and C equals to 43 degree. Okay, so this is how you find that, and that is how it goes. All right, good. I'll sketch the triangle. Okay. So we have the possible triangle, and we have the values, and then there can be more than one triangle. Okay, so in this triangle we just solve and we got the values, but then this triangle, you know, sine is positive. Sine is positive in the second quadrant. In the second quadrant, right? In the second quadrant. So that means B can also be 180 minus 77, which is 103. Okay, and the other one 103, and the other one can also be, what do we have there? C can also be what? 180 minus 60 um, plus that, and we can also get the value of C as 17. So if we have this, we can also have C to be equal to, what do we have then? What's the value of C before? So 43. So if we subtract here, we can have that C equals to 17 using sum of angle in a triangle. So that will be 180 minus 60 minus 103, which is 180 minus 163 degree, which is 70 degree. But I think getting the first value is always okay. You may not be asked to get in the other quadrant because that is actually advanced for you.